All right, well, welcome to the, what month is it now? November Northwest Straits chapter meeting, Surfrider, and welcome all of the Western Washington University Surfrider Club students as well. My name is Eleanor Hines. I am the chair of the Northwest Straits chapter. And tonight we are joined by Liz Shotman, the Washington regional manager for Surfrider here, and she does a fabulous job of making sure all of the Washington chapters stay on track. She's a wonderful cat herder, among many other things. She has an extensive background in biology and conservation and education and lots of other things like that. So she came on right as COVID hit back in March, and I have to say she's been doing a fabulous job of keeping us all on track. And so speaking of keeping us on track, she is going to present to us tonight on, she's going to shed some light on seabed mining because this is an upcoming topic that our Washington chapters are going to be following. So we figured it would be great to know a little bit more information about it. So with that, oh, I also wanted to add a fun fact. Her favorite fish is the mola mola, and she also likes to take up all kinds of fabulous hobbies like ham radio and stuff like that. So without further ado, Liz, take it away. Thanks.
Thanks for that amazing introduction. That might have been the best one I've ever had. So I appreciate that. And I do love mola molas, and I do like to collect skills that are fun because what else can you do during these times but read quietly on the couch? I don't know. Anyway, so yeah, I'm going to talk about seabed mining. I will preface this by saying I am not an expert in this. I've just been doing a lot of research recently because of our campaign here in Washington State, which I will talk a little bit more about towards the end of this presentation. And I also want to, so I will do the best I can to answer any questions, but I will maybe have to get back to you with some specifics that you have, questions that you have. I do also want to acknowledge that Pew Charitable Trusts has been one of our big partners leading this statewide effort to ban seabed mining. So they've provided a lot of the resources and information that I'm about to go over. So I just wanted to sort of acknowledge their efforts and contributions as well. So I'm going to talk a little bit about what seabed mining is and how it happens in the world and how it will likely affect our coasts and what we are doing about it here at Surfrider. Whoop, whoop. Hold on, there we go. All right, so I'm going to start with a quote by Sylvia Earle, a pretty famous oceanographer and badass female scientist and explorer. And it basically talks about, the fact that we don't really know what's down there. And so we don't even know what we're going to be losing if we start, recklessly extracting resources without knowing the consequences. History is fraught with these hard-earned lessons on the dangers of destroying that which we do not understand. And I would argue that the deep sea definitely falls into that category of what we do not understand. They estimate that we've only identified like 0.01% of the species that are down there. And more people have been to the surface of the moon than have been to the deepest parts of the ocean. And so I just wanted to start off with this critical need to sort of take a precautionary approach when we're talking about seabed mining or anything really. All right, so what is it? The definition is extraction of minerals and metals from the sea floor. So a lot of what I'm going to be covering today is a lot of deep sea mining, and so below 200 meters. But I do want to distinguish it from other types of seafloor mining, including like sand and gravel and shell mining, which has been around for decades. It has its own suite of like issues and consequences, but it's used for things like beach renourishment. But I'm not really going to be talking about that so much as the industrial extraction of those hard minerals and metals. So what's out there? Where is it? And how do we get to it? My mouse isn't, there we go. So there are, when you talk about seabed mining, there's three kind of the big three that you often hear about. And so there's the manganese nodules, which are basically like potato-sized lumps that are just sitting around on the seafloor. So these are full of things like copper and nickel. They have cobalt and lithium, so really important for things like batteries and such. And the way you extract them is you just kind of like vacuum them up or pluck them off the seafloor. You don't have to like chisel them out of stone. You just collect them, which seems pretty benign as far as mining extractive technologies go. But it's actually pretty destructive for those habitats because you're removing the only hard substrate that creatures have down there. Everything else is like soft mud. And so you can see in these pictures on the bottom here, you have like corals and sponges and things that'll attach themselves to these nodules because that's the only thing around that's like hard that they can hold on to. And then you have all these other communities of sea anemones and all other corals and things that continue to grow on top of those other creatures. And so when you remove those nodules, you're removing the only like hard surface for things to grow off of. And when you do remove these, they don't come back. It takes like a million years to grow a millimeter of these nodules. So once they're gone, they're gone. So, and then this is an image of an actual machine that a company has made to extract these nodules. All right, moving right along. So the next type of seabed mining is cobalt-rich crusts. And so these are located sort of on the top surface of seamounts, which are underwater mountains. And they are full of also cobalt, manganese, and other rare earth minerals. And seamounts are, excuse me, so to extract these, you have to plow them off of the surface of the mountain. And so it's sort of like mountaintop removal. So it's really destructive. Now this hasn't actually happened yet. We have the technology and we know how it would go down, but we haven't really extracted these crusts on an industrial scale anywhere in the ocean yet. And so we don't know for sure what kind of effects it'll have, but we know they won't be good. And we can kind of look towards deep sea fisheries to sort of see what the effects would be. And they're not great. One study looked at deep sea trawls, so like just dragging a net across these seamounts to catch fish. And so it's just knocking corals over. It's not even like scraping up the rock. And it still is completely devastating with losses of up to 50% of the species, that no recovery or very little recovery is seen like 15 years later. And so we can guess with a lot of certainty that this will be a very destructive mining practice. Which is really concerning because seamounts are like oases in the desert. So they're sources of upwelling where like cold, nutrient-rich, like oxygen-dense water kind of hits the seamount and flows to the surface, and it fuels a lot of primary productivity. And so that tends to be like biodiversity hotspots that are full of sharks and whales and turtles and really important for commercial fisheries and things like that. And I've also read recently that whales use them as navigational markers. So that's kind of cool. And the third main source that we usually hear talked about in deep sea mining is seafloor massive sulfides. And so these are kind of like hard mineral chimneys that build around hydrothermal vents, which are found in the deep sea, kind of along tectonic plate areas. And these are super cool because the majority of life on Earth derives its energy from the sun. And so it's all from photosynthetic organisms, are sort of the base of that food chain. And that's everything we interact with and eat, and our pets and our plants, everything. But these are actually one of the few communities where the sun could go out and they would probably be okay because they get their energy, they're chemosynthetic. And so all the minerals and chemicals and heat that just comes right out of the Earth's crust fuel these communities. And so they're really unique. We don't know a ton about them yet, but they're full of gold and silver and copper and some other metals like that. And the way you harvest them is you kind of knock them down, smash them up, and then suck them up to the surface. Oh, I have another picture of these guys. So here you can see like some pretty severe equipment that one of the mining companies has built specifically to extract these massive sulfides. And you can see like these really colorful deep sea communities that build around them. One of the cool things though is that unlike most of the habitats we've already talked about, these are slightly more dynamic and used to some disturbance, what you would call catastrophic disturbance, because like sometimes the vents will go dark and will stop pumping out hot chemical laden water that feeds them. And sometimes they'll just pop out in a new place. And so they might actually be a little bit more capable of dealing with disturbance like mining than some of the other habitats. But again, We don't really know because it's very hard to study the seafloor. All right, so those are the three main things. You'll also hear about like gas hydrites and things that are like crystallized gas that aren't technically minerals, but there are a lot of resources, like other resources that are located scattered about the seafloor that I won't talk about, but are pretty interesting. But what are the effects of seabed mining? So there's a lot of them. Obviously, the physical damage at the extraction site is pretty devastating. You have like localized mortality. So whatever creatures are growing on there are probably going to get smushed or hurt or damaged. But you also have harder to predict and more widespread issues like noise pollution. So if you think about the deep sea, it is cold and dark and quiet, and it works on a very slow timeline. And so when you bring all this industrial equipment with loud noises and bright lights and disturbing everything, you're going to have a lot of effects. But because we know very little about the deep sea, it's kind of hard to predict them. But we do know that there will be noise pollution, and we know a lot of marine mammals and other species use sound to communicate, so it'll interrupt those communications. You also get light pollution. So I think it's like 3/4 of the deep sea species we know of use bioluminescence or light to communicate or find prey or attract mates or distract predators. And so shining a bunch of bright lights, we don't really know what it'll do, but it'll probably interfere with their ability to live their lives. And then you also have thermal pollution. And so it's really cold in the deep sea. It can be like 0 degrees Celsius. The pressure will actually keep freezing temperatures, like it'll keep the water liquid. It won't freeze solid because of the pressure, but it can be absolutely freezing cold. And so when you pump that water to the surface where it's very warm, process what you're going to process, and then shoot that water back down into the water column, you're gonna jack up the temperature in that water column with unknown effects, probably not good. And then you also have conflicts with other industries. So example, fisheries are probably going to be affected, both at these sites and nearby. And finally, we have sediment plumes. And that's probably one of the biggest issues with seabed mining. And there's 2 plumes that you have to deal with. So there's one at the extraction site called the collector plume, which you can see in this little diagram here. And so you're actively like smashing things up and sucking them up. And so you're stirring up the bottom. And so you have this plume will kind of settle in sort of a nearby area and sort of just bury the local critters. But a lot of them are filter feeders or like really soft and gelatinous, and it's just not a habitat used to disturbance. And so there's going to be some immediate but fairly localized effects at that collector plume. But then you have the dewatering plume. And so when you suck all that water and you process whatever you're going to process on the ship, you have to get rid of a lot of that excess water, which are essentially mine tailings. Like they're laced with heavy metals and other minerals and things that aren't typically released into the water column. And so there are definite effects with smothering, toxicity, turbidity. So like just a lot of sediment in the water column will interfere with light. And so all those creatures that communicate with light might not be able to do so. And it also interferes with buoyancy. If you're like a gelatinous jellyfish and a bunch of heavy sediments like settle on you, like it affects your ability to migrate vertically in the water column. And again, a lot of the modeling that has been done has been on the collector plumes. And so we have a little bit of an idea of how far those plumes will travel and what kind of effects they might have. But we've done very little to study the dewatering plumes that are released out into the water column. But we do think that they will travel far and wide, probably at least, several miles away from a site, depending on how high up in the water column you release that water. And one of the studies I read was like about 50,000 cubic meters of tainted seawater would kind of occur every day with some of these potential sites, extraction sites, which is concerning because 90% of the livable volume on Earth is the water column. And we don't know a lot about everything that goes on in there. And it's where a lot of microbial action happens, and microbes are huge drivers in global carbon dynamics. And so it was just a couple years ago, we discovered a new species that takes carbon and turns it into biomass. And so like, we don't really know what the effects on those microbial communities will be either. And so that's another kind of concerning concerning aspect. And again, just to drive home the point of like, whatever we do down there is going to have very long-term consequences. It's very expensive to study the deep sea, and so there aren't a lot of empirical research studies to point to, especially long-term ones. But one of the famous ones is called the Discal experiment, where they basically plowed like 11 kilometers of seafloor. They didn't even extract anything. They just drug a plow over it, and then periodically revisited it. And 30 years later, you can see these top two images are, I think, the extraction site earlier. And then I think these are more modern pictures on the bottom here. And you can see the plow marks are pretty much still there as is. And then this bottom right picture is the experimental control. So that's where they didn't actually plow anything. And it's hard to see in this picture, but you can see there's like sponges and critters, there's a little crab there, versus the plowed area. There's just a lot less biodiversity. It has not been recolonized even decades later. So it's just really important that we take it slow when it comes to like figuring out how we're going to extract resources if we do from the deep. All right, so why are we dealing with this? Why now? So there are a couple of reasons. One is that we're depleting terrestrial resources. And so we've mined a lot of the easily mineable resources on land. And so we're starting to turn to the deep, while at the same time, we're seeing a huge uptick in demand. Part of it, ironically, is because of the green technology revolution. So all of the LEDs, all of our wind turbines, our solar panels, our electric cars, every device we use, it all requires these rare earth minerals and metals. And so that's been a huge driver. And so while we've known these resources have been down there for decades and we've had the technology to theoretically extract them, it hasn't really been financially viable because, it's just been easier to mine on land and the demand wasn't there. But those two factors combined with improving technology has made this a financially valuable thing that we're probably going to start seeing in the next decade. So companies are actively trying to get leases and exploring what's down there and identifying those resources with hopes to extract them. And in our country, we've even had some executive orders that kind of indicate that our government, in addition to global industry, is looking to the sea through efforts of seafloor mapping. And we've also designated some of these minerals as like national security because they're so valuable in things like communications and other technologies. So we're all looking to the deep. So who's in charge? So a lot of what I've talked about in this is resources that are often located in what's called the exclusive economic zone, which is usually 200 miles out from a country's shoreline. And a lot of them are also in international waters. But you can see like all along the Pacific coast here, we have resources in our EEZ, which is this kind of light area here. And I'll show another map soon that has kind of more zoomed in on our state waters. So the regulation of these resources in international waters is governed by the ISA, which is the International Seabed Authority, which is sort of a group from the United Nations Convention on the Law of the Sea. And so they're still undergoing, like updating their own regulations on how we should manage these resources as a global community. They're actually due to publish updated regulations in July. So it's still something that we're working with on a global level. But here in the state of Washington, in our waters, we have no regulations. And that's what we're trying to change with our campaign that I'll talk about in a second. But Oregon banned like seafloor mining in their state waters in like the 90s. So right now we don't really have any specific regulations. And that's why we're partnering with Pew Charitable Trust to try to protect these nearshore waters. And you can see in this map, so this little section here is the Olympic Coast National Marine Sanctuary. So these little green dots are known resources of various kinds. And so these ones have some protection because they're in the sanctuary. But here, a little bit further south on the coast, you can see some of these resources are in fact in state waters and don't really have any protections. And so that's what we really want to try to get at. Whoops. Before industry kind of picks up. There's also, I read a paper from the 60s that talked about black sands that are located in Grays Harbor that have, I think like titanium and other elements kind of mixed up into these black sands. And again, like, I don't know for a fact like how devastating it would be, but like the fact that our shellfish industry is located in these nearshore waters is like very, just one of the many reasons that we need to be very cautious when we're talking about releasing toxic sediment plumes into our nearshore waters. And so, yeah. Finally, we can move on to solutions. So some of the things that you can do as an individual is, of course, support your local organizations that work on these issues, like Resources and Surfrider Foundation, your local water keepers, Pew Charitable Trusts. There's a ton of organizations that work on protecting the oceans in various ways. So yeah, becoming a member, supporting them through donations or through your volunteer efforts is always helpful. Obviously, reduce, reuse, recycle. But I would argue also redesign. The one good thing about metal is that you can recycle it infinitely. It's not like plastic where every time you recycle it, it kind of degrades and you only get like 1 or 2 rounds of recycling before you kind of have to throw it away. Metal is theoretically infinitely recyclable. So if we were able to design our products so that it's easier to take those resources out of them at the end of life and put them back into new products, that would significantly reduce the demand rather than throwing these valuable resources into a landfill somewhere or back in the ocean in the form of trash. There are debates over whether terrestrial sources can supply the growing demand. I don't have the answer to that question. There are some that say with better recycling and better technology, continuing mining what we know is out there on terrestrial lands, we can supply that. There are others that are like, we need to mine the deep. But I would argue that if we were able to promote a circular economy and reduce our own consumption, that does a lot to drive the demand down until we can find a solution and get some regulations in place. And one of the specific action items that we're promoting right now as part of our statewide campaign to ban seabed mining in state waters in Washington, so that's the extreme low tide out 3 miles, is we are circulating a business sign-on petition to try to collect those signatures of all the businesses and all the coastal communities that are like, we don't want this in our waters. This jeopardizes our tourism, our fisheries, our recreation. Like, we just don't want it in our waters. So if you are a business owner or you know a business owner, we highly encourage you to share this and get as many signatures as we can so that we can bring that to the legislator. Gus might be able to post a link to our blog post that has a lot of this information, as well as a link to the letter in the chat, because he's usually really good at that. I don't know what's going on because I can't see the chat right now. And yeah, and then I will say he can plug a little bit of the policy work that he's been doing if he's ready.
Whoa, 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 whoa. Too many things at once, Liz. This is amazing. I was trying to I'm a male and I need to only do one posting at a time. Let's pause first and see if there's any questions while I post these links, and then I can touch on the policy stuff a little bit.
Call. Questions, anyone? Oops.
And for questions, feel free to enter them into the chat box, or I think we're of a size that folks can also just, shout it out if you want to, or raise your hand.
Hey, this is Quinn Butler. Sorry, I am late. Good to see you all. Hopefully you can hear me okay. Question for Liz, maybe Gus. You mentioned that this has been banned in Oregon since like the 90s. Is there an opportunity to look at what the policy is in Oregon and try to mirror that in Washington? I'm just curious as to why Surfrider is going the route of engaging businesses for Washington State, if that's seen as the most viable option.
Yeah, I can answer that. Absolutely. We are using Oregon's language kind of as a starting point and identifying how, Oregon and Washington are slightly different. So, kind of taking what they did in Oregon and modifying it a little bit so that it jives with Washington's RCWs and all that. The business sign-on letter is more just a way to grow support for this effort. recognizing that, coastal businesses would be the most potentially impacted from the threat of seabed mining. So it's just a way to kind of demonstrate support to legislators, especially to those that have a potential financial impact if seabed mining were to go forward in the state waters.
There were 2 additional questions in the chat box. One is, are there protections outside of Washington state borders?
I'm not sure what the regulations in federal waters are right now. It's something I've been meaning to look up, and I just haven't had time yet. And there are international waters. So most of the research you'll find out there is focused on the international waters and regulations, because that's where the majority of these resources are. And I honestly have spent a good bit of time trying to identify, find information on what resources are in our waters, both federal and state. And it's not easy. I haven't found much, honestly. It's either it's buried, or what I have found is very old. It's from decades ago. And again, it's so hard to map and identify those resources. It's just very expensive and technical. And so I don't know if that information is out there, and if it is, I haven't found it yet. But as far as the federal regulations, I'm sure we have some. They're probably vague and not very specific, if that's my guess, just because that seems to be the case, because this is a new industry, and so we don't have those details hammered out.
Which somewhat relates to the next question, which is, are there any known resources in the Salish Sea?
Yeah. There are, I can go back. Let me see if I can So I'm not sure how much surveying of resources have happened in the Straits or in Puget Sound. I feel like I've read that there are some resources there, but I can't remember off the top of my head what they are. This map shows some heavy mineral deposits on these green dots that are located on the outer coast. I don't know if the lack of dots is from a lack of surveying or just a lack of resources available. Again, that's something I've been trying to find more information on and have failed. So if you know somebody in the geology department, I am happy to continue the search, because it's definitely really useful information to have.
Well, and maybe that's a good segue where I can kind of tie in on the policy side of things. Right now, as part of this effort, as I mentioned, we're trying to develop some legislation that would establish a prohibition for Washington's territorial sea, but also at the same time provide protections for the Strait of Juan de Fuca and the Salish Sea as well, and try and be as encompassing geographically and ecosystem based as possible. So we're currently in early conversations with some legislators, trying to develop some draft language that could be introduced this coming legislative session in January. So hopeful that we can kind of get all the ducks in a row, and get that bill dropped and kind of, move this forward, without the threat of an active proposal to actually go and do something, with a gun to our head, and threatening our coastal resources. So that's kind of what we're working towards in the short term. On a larger, more national and maybe even perhaps international scale, is just, the outcome of the election last week, and the really positive news that we saw, and that the current administration, as a matter of fact, is on the way out the door. And they were the ones who had established those executive orders, who had sought to develop this new industry off of America's coastline. So that is a positive thing. However, the interest in and demand and potentially developing this resource and extracting it might still be there. And that's why we need a new administration who is more inclusive of ocean protection efforts, to update our laws and policies to make sure that we're taking the precautionary principle and protecting our really valuable coastal communities and coastal economies that are associated with the existing jobs and industries that we have. Oh, and then I see Jamie's question as well. So one thing to note about this effort is that while we're doing this here in Washington, there are simultaneous efforts that are happening with some of our colleagues and friends down in California. Pew is also working with a number of folks down there in California to kind of do basically the same thing. And so hopefully in the next year or two, we will be able to get Washington and California both with updated laws and policies for protecting our state territorial waters. And then that would have California, Oregon, and Washington protected for our nearshore waters, and would send a strong signal to the federal government that we need to protect the federal waters as well, from 3 nautical miles out to 200 nautical miles in what's known as the United States exclusive economic zone.
And then Jamie had a second question too. That was, can you remind her, well, all of us really, what you said cobalt was used for again?
Yeah, so it's used for a ton of things, but primarily lithium ion batteries. So it's actually one of the main components in lithium ion batteries. So like most of our rechargeable devices. It's also used for like alloys. It tends to be really heat resistant, and so it's incredibly valuable for like wind turbines and gas turbines and like, you know, heavy equipment and things like that, like precision equipment, aircraft engines. It's also used in like jewelry, prosthetics, like internal, like fake hips and stuff. I think it's used in like dental implants. It's used to make blue dye. So it's incredibly valuable, but I think the lithium ion battery component is one of the primary drivers for the increase in demand for cobalt. And the majority of cobalt comes out of, I think, Zambia and the Congo, like the Central Africa region. And there's a whole list of horrible human rights and environmental problems associated with those African mines for cobalt specifically. So there's no good way to extract a lot of these resources, I guess. I don't know. Which is why we need to recycle them as much as possible. Any other questions?
Yeah, it looks like Quinn had another one here. This is encouraging to hear about Surfrider's proactive approach, stopping seabed mining before it happens. Thank you, Quinn. Have there been any known threats or close calls in recent years to this happening off the Washington coast? I mean, you know, I think that the the largest close call has been over the last 4 years with the current administration issuing the executive orders and the potential for exploration and extraction, even though it hasn't really moved with individual specific proposals. Prior to that, at least to my knowledge, I know that there was maybe some exploration that was done off the Oregon coast, you know, quite a while back for some placer minerals, like in the late 80s, early 90s. And then, you know, some of the research that Liz noted and what had been identified previously. I mean, some of those studies go way back and into like the late 60s when, you know, they were doing some core samples and also doing some exploration for oil and gas resources as well. So a lot of times this issue kind of gets lumped into that interest in extraction of oil and gas resources, which folks might recall was definitely a significant threat when in 2017 the Trump administration proposed to open up 90% of America's coastline to oil and gas extraction. So that's something we've also been working on, and we're really looking forward to making a permanent ban on offshore oil and gas extraction at a national level here in the next couple of years. Thanks for the great questions, Quinn.
Any other questions?
I just got to say, as a rock hound, that looks like a really cool geode kind of thunder egg, almost petrified wood
Right?
sample that like I would be really, really stoked to have in my collection. But yeah, don't need to go to extract it off the seafloor to get it.
Oh yeah. Oh yeah.
We did have one more question. That was, do we know how big the industry is currently internationally?
I mean, I don't know the like numbers as far as like the valuation of the companies, but so this is actually a blog that I'm looking at from Twin Harbors Waterkeepers, because they're one of our partners in this campaign, and she just recently wrote a blog post. So like De Beers is a big one. A lot of diamond companies have actually been doing a different kind of seafloor mining. It tends to be a little closer to shore for diamonds. So Namibia, Africa is a place where they've been mining diamonds from, I think, their exclusive economic zone. But yeah, there's these companies are, I think, primarily terrestrial mining companies, which, you know, probably have a lot of resources available to them, because it's expensive to mine the deep, and you have to explore it first. And so like that's, you know, they have to have a certain amount of resources to be able to find what's down there, you know, apply for the permits. And then part of the regulations, I'm not super familiar with them, but the International Seabed Authority, they're supposed to regulate both like who gets to profit from the extraction in international waters, because they're supposed to help prevent really developed companies from exploiting waters off of less developed countries, which is already kind of happening, but not on an industrial scale yet. And so these companies also have to fund like research. I don't know, like the arguments I've seen are like, it's not enough. But in order to apply for a permit and get a lease to extract these resources, these companies have to demonstrate like a baseline understanding of the ecosystem before they go in and mess it all up. So yeah, I don't know how much money they have, but it's probably a lot.
Any more questions? I'm not seeing any. So thank you so much, both Liz and Gus. I really appreciate you giving us a lot more knowledge on seabed mining. And as I think Quinn noted, everything changed on my screen. It's really nice to be working on an issue where you're trying to prevent something down the road, rather than there's this company trying to propose this project that's going to do all this environmental damage. So thank you for looking, 10 steps ahead, rather than, trying to make headway on some damage that is trying to be pushed through already. So
so much in conservation is like, well, let's try our best to clean up this mess, instead of like, hey, let's ounce of prevention's worth a pound of cure, no, okay. So yeah, it feels good to be able to try to get ahead of something like this.
Definitely. And, as far as the solutions go and some of the ongoing efforts that we have right now, stay tuned. We hope to have some really good news in the near future. We'll be providing updates in the coming months ahead, and hopefully there will be some really, great legislation to rally around in the upcoming session, which is going to be all virtual. So there'll be hopefully a lot easier access for people from Bellingham and the Northwest Straits area to be able to chime in and hopefully provide some supportive testimony, or writing letters, picking up the phones and contacting your elected officials.
And I will say, just to finish it off, if you haven't signed up for your local chapter's newsletter, I highly encourage you to go to their website and do that. But we also have a regional website, a Washington Surfrider website, and we send out a monthly newsletter through that has more statewide updates typically. So that link that Gus posted to the blog post that has the seabed mining sign-on letter, if you scroll to the bottom of the page, there's a sign up option there. So that's where we will probably send out some of these updates on seabed mining and other campaigns.
Awesome.
Right on.